Hello, I'm Ariana Hurtado, Editor-in-Chief with Offshore. Today we have MODEC's Head of Floating Production Solutions Business Unit, Soichi Ide, to discuss current FPSO trends as well as decarbonization strategies, digitalization, and the path forward for the offshore energy industry. Welcome, Mr. Ide.
Hi, Ariana. Great morning for me. Great afternoon or evening for you. Thank you.
To kick things off, I would like to ask about MODEC's design, construction, and equipment strategies. Typically, standardization helps reduce costs and shortens construction time, but it may not suit specific field requirements, such as reservoir characteristics and water depth. What are your thoughts on bespoke versus standardized FPSO designs, and what are operators asking for?
Right. Interesting questions. You know what, this standardization attempt is, I guess, over 20, 30 years. But I think when, like, a step back a little bit and talk about FPSO. So I always talk this one, particularly for our engineering folks. They love to say every FPSO is different. But when you look at FPSO from Google Earth, from the satellite or wherever, right? And when shoot the FPSO, let's say in Brazil, right? So it is always VLCC design, always flare towers in the front, and like a spread mooring, and like a topsides is basically fitting entire tops, like a hull, right? So if you look at from that level, every FPSO looks same. So it's just a matter of like looking at the same things from left or right. Right. So I would say, yes, every FPSO is different, and there are a lot of features that we need to accommodate for field specific, but we have a ton of things we can standardize. And I would say maybe 80% of the things could be standardized. And that's something what we are driving as well.
That's really interesting. Next question. Yeah. FPSO topsides must accommodate processing equipment, utilities, and storage within limited deck space. In addition, the weight of this equipment must be distributed in an optimized manner to maintain stability. How are your latest designs optimizing topside space?
Sure. Very first of all, MODEC like company is not exactly to build a FPSO. Our business basically is to build and operate. So our design has evolved a lot, not designed to build, but designed to operate and maintain. So that's something what we pay a lot of attention, how this facility that we are going to deliver and use are going to maintain its function over 20, 30 years on the oceans without any dry docking. Right? So that's a kind of design principle. Then we pay a lot of attentions how the maintainability is maintained, how operability is achieved. But at the same time, from construction standpoint, FPSO design by any company is a kind of modular design. So it's a kind of Lego block, top-sized modules installed on the deck one by one kind of thing. So it's a matter of how to modularize or how to package it into construction phase. So it became bigger and bigger, like a topsides became bigger and bigger. That predominantly driven by field complications and the size of the facilities. And as a matter of fact, then topsides module became bigger and bigger. And it requires to install during construction. That requires a big crane. So this crane capacity sometimes is a constraint. But once you put those modules on top of FPSO, then productivity is far less comparing with the construction on the ground, which is the beauty of modularized constructions. So the very, I would say, classic way of thinking is to reduce the work on board. That means topside must be bigger. Right? So, but like quite recent days, we have a lot of interesting learning as well as analytics, if that is true or not. And the short answer for us, again, for our own project execution methodology was not. Because when we build the larger modules on the ground, we sacrifice the productivity on the ground. So that means takes more time and more, I would say, complication to manage interfaces. And yet, we couldn't enjoy entire schedule optimization. So our drive currently, of course, without sacrificing operability and maintainability, our current drive is to make the topsides compact and smart rather than big and comprehensive. So that's a recent change we are adopting.
Okay, thank you. I appreciate that insight. And are you seeing more oily versus gassy FPSOs being demanded? And how does that change the processing equipment requirements? Additionally, how does that impact the topsides layout and equipment requirements?
Sure. Yes, that tendency exists. Well, all in all, I guess oil field is easier to develop for operators. So, and as well as oil is easy to market. So that's how oil field has been prioritized in the market field. But at the same time, when you look at Brazil, for example, a lot of associated gas was re-injected. That means big gas reserve still is on the ground. And there are a lot of great discoveries with high GOR. That means more gas than oil. And the world currently requires sustainable gas supply to respond like an energy addition topic, and energy demand itself is increasing. So we still need to maintain this like a lower carbon sustainable fossil fuel, which is gas. So I think trend of gas facility increasing is quite obvious. And in terms of facility standpoint, previously our classic FPSO, particularly for the deep water, re-injected the gas. That means deep water means higher pressure. So topsides is oil liquid, and that basically means like a smaller size of piping, if you like, comparing with gas piping, but that requires higher pressure to re-inject. Now it's gas, so gas to produce, so more volume, that means bigger piping, but maybe less pressure. So of course, topsides design is going to be different because larger piping means it's really hard to handle the design and the layout on board. And that is going to basically congest our entire topside. So we need to brush up our, I would say, layout philosophy. What's the best way, again, without sacrificing operability and the maintainabilities. So yeah, there are certain challenges, but it's a bit of known challenge. MODEC has been working with gas FPSO since like 15 years ago. So yeah, I mean, it is a kind of refreshing challenge, if you like.
Okay, great. And you touched on deep water, and that kind of segues into my next question. Well, half of FPSOs around the world are in shallow water. How do the mooring designs have to change in shallow water versus deep water? And does a shallow water deployment change any other design considerations?
Right. Great. Okay. So like a deep water means more costly and typically further from the shore. So for any operator to materialize or basically decide the investment decision for the deep water field requires bigger reserve. So bigger reserve means bigger facility requires or longer operation required. So comparing with shallow water and deep water, there are significant difference here in terms of size of FPSO first. Again, it's not necessarily, I mean, they are big, gigantic, like a shallow water field as well, but it's a natural tendency. Right? Then deep water means deeper location with a mooring system. So that itself has own challenges because no one can dive into that location. So every installation and every construction activity on the deep sea is basically robotics. So there are certain natures. On the other hand, the complication for shallow water is when the shallow water basically means 50 meter, sometimes 40 meter. And when you look at the FPSO VLCC size, the hull depth is 30 meter, right? So entire 30 meter is not going to be sunken under the water, but let's say 20 meter. If FPSO is fully loaded by crude oil, then 20 meter from the sea line, like a sea level to the bottom, is going to exist. So if like a shallow water, like a 30 meter, 40 meters are there, then basically the room between the seabed and the bottom of the FPSO is just like this much. So we cannot lay catenary mooring system for sure. So we need to have other methodology like a tower yoke and whatsoever that we have delivered to Mexico. So that's completely different mooring system, more for rigid mooring system or fixed facilities rather than like a mooring chains and those lines with the catenary kind of layout. So that is one. And the other things is like production risers or gas risers or whatever must be again in that small like a space. So that's challenging to lay out the entire mooring system as well as like a flow line, not to be congested and not to be hitting to the FPSO, which is basically which causes the damage to the flow line. So that is no design to hit the FPSO. So the unique complication exists in the shallow water FPSOs.
Interesting. Okay. Next question. Industry-wide, regarding FPSO construction in the shipyard, are there still bottlenecks, scheduling conflicts, and/or supply chain disruptions, or has the industry moved past these mostly pandemic-related construction challenges?
Well, challenging during pandemic was really horrible. So that was super challenging. Predominantly from like our own mobility into the country where we are constructing, as well as supply chain disruption. Like we cannot deliver this one to country A, country B, whatsoever. So that was complicated. But then post-pandemic world is again stayed complicated in different way comparing with pre-pandemic. I think combination of these geopolitics complications, the supply chain is still quite disrupted, including like a sea lanes and which is the secure sea lane and how we can deliver this equipment from, let's say, Eastern Europe to Asia kind of thing. So that the supply chain itself is complicated. At the same time, I guess the world energy demand is very stably increasing. And that basically means everyone wants to produce energy. So the demand is high, while supply is not necessarily catching up to that extent. So even equipment suppliers are quite tight now. So it is very seller's market. So to secure equipment is not easy, even for us. Then coming to shipyard, then shipyard requires spaces and skill sets and maybe certain size of dry docks, and that is still a bottleneck. So what is and they can be busy. This shipyard in China can be busy not for offshore projects. They are super busy for commercial vessels such as LNG carriers or crude carriers, container vessels, and whatsoever. So yeah, supply is quite tight. So what is so important and far more important than even pre-pandemic days is how we can develop partnership with those supply chain, including yard as well as equipment suppliers, and how we can then tie that tight partnership for both of us to optimize our own management system to deliver even more productive as well as faster.
Okay, and on a somewhat related note, to the extent that some shipyard or supply chain challenges remain, does 3D printing and modular construction offer any solutions?
Well, 3D printing, like a 3D metal printing, can work for temporary solution, like a sudden breakdown during operations and whatsoever. So that is good, but that is not yet for main delivery of FPSO. Like a question is, can it be? Maybe yes. That's a bit of like a chicken and egg, whether the quality of a 3D printing solution can withstand like a 20 years operating life kind of things. It's quite interesting, I guess, technologies that we always need to catch up with the latest technologies. But putting like a 3D printing a bit aside, 3D printing may work for prototyping. And if we try to introduce new equipment in a new layout in a certain way, maybe it works in the smaller scale, but not for the bigger scale, like entire FPSOs. Modular design for sure. I think modular design has been always adopted, I guess, since millennium. And that's a kind of main construction methodology that every players are adopting. I think how to modularize and how to design it is a bit of, I would say, feature of each contractors. And as I said, MODEC has evolved in a certain way. Yes, we are using modularized design, but we have a kind of aha moment. And we revisited our design drastically. And that reduced the entire topsides weight, as well as shorter schedule, as well as easier constructions, and easier even maintainability, because we can have more space on the topsides. And we are also modularizing hull construction part as well, which typically wasn't the case before. And so we are adopting certain interesting construction methodology for the Gato Mato project for Shell, for example. So yes, modularized concept works to optimize and like improve the productivity.
Thank you for breaking down all your insights for us. Moving on to the next question. With significant demand for FPSOs today, how do you see the different strategies for delivering an FPSO to the field in the quickest and most cost-effective manner? New build, conversion, or refurbishment and redeployment?
Yeah, there are a lot. There are a lot, and we can talk this on over an hour. But I guess in a nutshell, for example, new build conversion is a matter of time and what we want to deliver. Right? As we made a couple of innovations for this modularized concept for the hull construction for new build. Now, new build hull construction is not necessarily on the critical path. So that basically means a great feature of new build that is basically designed for like operate. Typically, conversion is from crude oil tanker, so we need to do a lot of things, but we don't have that constraint. So we can design for FPSO, and we can design for FPSO to operate. So the great things on the new build can be materialized without impacting entire critical path schedule. So that is as of today. So currently, that part could be debottlenecked. Refurbishment upgrade is there. There are a huge industry problem for the old asset, how to decommission or how to reuse that one. Again, in the history, FPSO by right is quite mobile and should be mobile. So there are a lot of conversation if we can redeploy facility from field A to field B whatsoever. It is not as easy as a disconnect and go and reconnect kind of things. But at the same time, this decommissioning as well as scrapping of this FPSO is becoming a big challenges for the industry. So why not reusing any facilities which is maintained well, or still can have a smaller conversion, a smaller repair to redeploy to the new field. There may be certain answers. I mean, some equipment need to be replaced, but I mean, that's a part of this repair and renewal kind of philosophy. But it should be far faster than construct FPSO from the scratch.
Okay, you made a lot of great points. Let's explore another angle, decarbonization. Regarding green FPSO solutions to reduce emissions, what do you view as the most feasible strategy? Having complementary wind or solar facilities, building a CCS component, or something else?
Right. I guess this renewable topic has been in the industry maybe 7-8 years. And at the end, the short answer is, I guess finally the solution must make sense. It must make sense in many ways, including feasibility of the concept as well as economical sense. At the end, somebody needs to pay the bill, and somebody needs to pay the time to develop. Right. So at the end, that is going to be converging into that way. So there are a couple of thoughts, of course. So MODEC is a very fast adapter of gas combined cycle gas turbine power generations. So this is basically to reduce carbon by improving the efficiency of power generation. So to generate the same power, we need less fuel. That means less emission. So that is one attempt. So we have 3 FPSOs on gas combined cycle system, and one of them is FPSO Bacalhau, which is just being installed in Brazil, waiting for the startup. So we will know how this performs. From the science or from engineering standpoint, we can reduce 20% of CO2 emissions from FPSO by combined cycle. So whether 20 is enough or big enough, that's a question. But of course, combined cycle will not entirely reduce carbon emission. But that's a step one. The next challenge that we are currently pursuing, as well as I guess this is going to be a kind of technology that the classic oil and gas industry need to seriously work on, is post-combustion carbon capture. That basically means removing emissions from exhaust of gas turbine. By the way, like emission from gas turbine or power generation is more than half of emission from FPSO. It is nearly 2/3 of emission. We have measurement of this one, but 2/3 of emission is from power generation. So if we remove this one and catch carbon and re-inject back onto the ground, then by right, we can reduce 2/3 of emissions. So that's significant. Like even our product is fossil oil, which is basically carbon, but we are discharging a lot of carbon during production of fossil oil. So we are really responsible to reduce this emission to be sustainable energy supply, and that lead into affordable energy supply. So this CCS is something what we need to see the next. Combination of wind or solar, again, it is the challenge of this one is solar shines only in the daytime. Wind blows when wind blows. So to depends on the renewable energy for the offshore production is not stable by nature. So we need a backup some way. So backup basically means standard and classic engines, for example. So we can do like we can use wind power during daytime, or when wind blows, then we need to switch over other ways. But then facility complications still exist. And that's where I said entire economics may need to make sense if that concept is materialized. Of course, scientifically it can work, but economically it must work as well.
I appreciate you sharing your perspective on that. You touched on gas turbines and lowering emissions, and that segues into my next question pretty well. Are you or your clients moving to larger gas turbines for power generation and or to lower emissions? And what else can be done in terms of power generation to help reduce emissions? Carbon capture, hybrid power systems, or electrification?
Right. Yeah, great things. And by the way, yes, like this larger power generation things can be thought. I think the current challenge as of today is larger turbine is wanted by many people, and the supply is really tight. So we can accommodate these things on design, of course, but and we tried, and even entire electrifications, then use big gas turbine engine to supply all powers. We tried, but we couldn't, simply because from timeline standpoint, how long it takes to deliver entire FPSO didn't make sense. So again, this is the typical economical challenge, as well as a bit of make sense of it. But attempt must be continued. So what is the optimal design? Again, like a gas turbine generator is very, I would say, high energy density power generation. That means higher output can be gotten from same footprint or same volume of equipment. But when you look at the world, like what is most efficient internal combustion system could be diesel, right? So we are also taking a look whether like a gas burn diesel cycle works for FPSO. That is bigger, of course, and that requires certain spaces, but maybe if we use Newbuild hard, we can use some space to accommodate this one. So again, nothing can be like a giving single answer to respond these low carbon solutions, but attempt and as well as wish must be there to reduce carbon. Then how part has a lot of answers. Like if we electrify, like Norway, if we electrify, and if we have power generation on board by typical fuel, but once other alternative electricity is available from the subsea grid that may be renewable, then we can entirely stop power generation and start to use electricity from renewable. So all in all, this requires very complicated, like a field design, as well as a lot of conversation with operators and ourselves, like a contractor, as well as maybe government of the field to operate. But I mean, interesting topic to optimize, and that may be very, I would say, localized topic than global topic. So for this region, this may be done. That region, that may make sense, kind of things.
Okay, thank you. Switching gears a bit, the Offshore editorial team is going to be publishing its second annual Offshore Brazil regional report later this year. So I'd love to ask you some questions more specifically about this region and MODEC's work there. First, how does MODEC meet its local content requirements in Brazil, and how does recent legislation in Brazil impact these requirements?
Sure. MODEC has been in Brazil since 2003, right? And since then, we other than like a construction, we are there for the operation of FPSO. And by the way, Brazil holds our biggest population of our employees. 2/3 of employees are in Brazil. So Brazil is our biggest locations, as well as you correctly pointed out at the beginning of the interview, the Brazil deepwater is the main or majority of deepwater projects. So we cannot ignore Brazil. So that's one. And I guess MODEC in the history is one of very, very few players who can work with local content construction in Brazil. It is not easy for many reasons, but we are quite successful. So we know what can be done. We know to what extent is making sense again. And we know how to work with Brazilian contractors and the yard. And again, as I said, 2/3 of population of MODEC is Brazilian. So it's nearly in-country kind of thought that we have long-standing a presence there. Recent legislation in Brazil, of course, I mean, intent of government is quite clear. How they can convert this industrial opportunity from oil and gas into local economy by the industry for the construction. So intent is right, intent is clear. I think how to is a difficult part in many reasons. I mean, two things. One is to what extent we need to do local content. So theoretically, we can build entire FPSO in Brazil, but economically that doesn't make sense. Maybe because of the maturity of industry in Brazil for certain part of FPSO constructions, and that takes maybe double or triple than other part of the world can deliver. So there are great balance, and we know that great balance. And the current drive by legislation, we are fine. We are comfortable with this one. We can do. I think challenge is more for how-to part. How is more, I would say, for example, if I take 30% as an example, we can use Brazil 30% of entire FPSO. That part is okay. And we know how to work with the Brazilian partners and whatsoever. That is okay. The difficult part is how to fiscalize, for example, that 30%, because that is a requirement. So somebody need to measure if I'm really doing 30% or 29 or 31. So that part requires a lot of complicated transactional, I would say, effort and procedure effort. And previously it was certified by third party in Brazil, but that requires a lot of complication, and there is no perfect answer made by Brazilian regulators. So that's a challenge.
Okay, and speaking of complications, what are the key challenges MODEC faces in operating FPSOs in Brazil's pre-salt regions, and how does the company address them?
Right. MODEC is the one delivered very fast pre-salt FPSO, which is MV22 Angra. So since then, we learned a lot. Majority of pre-salt facility existed in the ultra deep water. So again, as talked earlier, there are certain technical challenges, of course, as well as design challenges, how to deal with these things. At the same time, pre-salt exists like deeper than really heavy salt rock layers. So the product that means basically gas and oil from pre-salt region behave slightly different from other regions. So we did a lot of operations optimizations. That includes, of course, topsides design as well as chemical management and whatsoever to maximize the yield of the productions. So it's hard to explain all of it, but there are different nature and features required for the pre-salt, predominantly in operation phase. And there are a lot of know-hows behind.
I see. And can you elaborate on the technological innovations MODEC is implementing in the FPSO Gato Mato project?
Right. A lot of when I say technological innovation, it is not like launching rocket to moon kind of thing. So there are pile of new things we have challenged. Main one, as I said, is changing the concept design concept of topsides. So we tend to build larger topsides to reduce the time during integration phase after we put the Lego block on top of FPSO hull. But we made out of box thinking and we completely reviewed this one. So we made topside smaller. Each topside smaller basically means more Lego block to build, but that reduced entire project schedule very drastically as well as weight. So basically amount of steel requires that the yard is reduced. That means like amount of CO2 is reduced during steel production, for example, or topsides construction. So that is great. As well as we did a lot of changes in the structural design that reduces the surface area of structures. So, for example, using tubular instead of H-beam, then that requires drastic. That results in drastic reduction of paint surface area. That means amount of chemical around the paint required over 20 years operation is significantly reduced. Right? And that is, by the way, challenge offshore because offshore has limited personnel on board. So even maintain the facility intact is not easy. So we did a lot of those design changes to accommodate those challenges in a longer operations. A lot of, I mean, we did this power system optimizations, as you said, whether to use bigger like a gas turbine generator to electrify everything or to distribute powers driver for every equipment. So we did several optimization study of this one. The main goal was to achieve the shortest schedule and the lowest capex, but we made optimum point for this one. So that's a bit of innovative way of thinking rather than classic way of thinking. We are doing a lot with how to design, how to build. So we now have very stable partners in constructions, predominantly in China. So the way how we design and engineer the facilities is completely different from previous days, earlier days. So now it's more for construction-driven engineering. So at the end, what we are going to deliver is one FPSO. So rather than looking at the schedule from front to the end, we just look at from the other way. So this is the product we are going to build. Then we are going to do the construction in this way. And that's why engineering must be done in this way and in this sequence and in this procedure. So that's how we change the way of executions. And that contribute a lot of time reductions as well as I would say less errors, if you like, to impact into entire time frame of the project. And we have other digital a technology as well. We are adopting both for construction and engineering and operations.
Okay. We'll talk more about digital technologies in a bit, but building on this topic, what other lessons has MODEC learned from its previous FPSO projects in Brazil that are being applied to current and future developments?
Well, a lot. I would say like over 20 over years of operations. What we have done is FPSO again is not to build, but to operate. So to operate over 20 years over the ocean, which is 200, 300 kilometers away from shore with a limited personnel on board to maintain is not easy, right? Without disrupting production. So that's how the main lesson is how to make sure this FPSO is going to maintain its uptime as well as safety, as well as production stabilities. Then how to make it happen. So like when you construct FPSO on the ground or repair something on the ground, that's easy. Well, I mean, easy means easier, far easier. If that offshores, then even small parts need to be delivered there, and there are a lot of complication requires. And of course, time matters. The production uptime can be only achieved only when every piece of equipment are functioning as planned or as designed. So any small piece of mistake can cause the entire shutdown of the plant. And we had a lot of learning from this one. So single critical element cannot be like a jeopardizing entire reliability of FPSO. So a lot of reliability in design. But at the same time, from the economic standpoint, as I said, it need to make sense. So you cannot build FPSO with a shiny gold with a lot of redundancy. Then it doesn't make sense. So that's a difficult part. What to be adopted, what shouldn't be adopted, what to be done, what shouldn't be done, kind of things are the key lesson learned. And at the same time, over the years, we have ton of data from operations. So now in the combination of just typical lesson learned from the previous, that maybe lesson learned from specific breakdown or incident whatsoever, that is a classic way of approach. But we have a ton of data, so we can use this one for the analytics, advanced analytics, how data tells, how data talks, then we have a great evidence of why we need to do it this way rather than that way. So yeah, Brazil grew us a lot.
Okay, great. Let's dive into the topic of digitalization. What areas are you incorporating digitalization and automation in your FPSO designs and systems?
A lot. My favorite topic, by the way. Yeah, MODEC, by the way, has in-house digital teams at several locations. I guess total headcount can be easily more than 100 plus people. That includes like a data scientist and data engineers, architects, as well as developers and UX, UI, whatever. So there are a lot of different concept or different organizational design for the digital, but we made a very conscious decisions to internalize those skills within us. So with those teams, for example, building FPSO part, we are doing a lot of digitalization effort from front office to back office. It's quite like including very basic, like if that is operation, then crew manning. We have AI running on crew manning, operation support automatizations. So that is other things. We have also predictive maintenance by AI, and we are doing this in over 7-8 years already in Brazil, and even we spin off that company to serve for other industry or other company. For design, we have a lot of interesting AI technologies we are using. So even for drawing check and the design check and the vendor drawing check, we are now adopting AI. So like previously was like engineers to compare two documents and two drawing and check one by one and like a red markers, like yellow markers kind of things. But now we are seriously implementing this one already in the production mode to use AI for drawing check or design check. Quite recently, of course, generative AI for sure is a topic. Now we have our own version of generative AI that doesn't contaminate proprietary document or information to outside of the world. So this is a private generative AI that can every employee can ask the data within us or any history of MODEC experiences. So that's one. Then very, very recent is agentic AI. So that is a specialized AI trained for certain purpose. So even to give some like an insight or answer to our employees, those several agentic AIs are working and collaborating to work to conclude answers, both on EPC and in the engineering construction world as well as operations. And cybersecurity is other things that becomes a biggest topic now. Like FPSO design and operate must be a kind of OT cybersecurity and the remote operations proof. So that is a quite like a default but latest technical challenges on the digital world.
Thank you. You touched on AI quite a bit. So following up on that, how is MODEC leveraging artificial intelligence and machine learning to optimize FPSO operations, predictive maintenance, and safety monitoring?
Right. Like biggest use of machine learning over, let's say, I think 8 years is predictive maintenance. So as I said, we have over 10 facilities in Brazil. That means really a lot of data. The beauty of operations is we have 10,000, 20,000 sensors that develops data every second, right? So the amount of the data is phenomenal. So how to use this data is a kind of state of art. And again, our objective is to maintain the facility safe and steady and higher uptime for our client to produce the energy as much as possible. So with using our own data on the facilities in Brazil and some part in West Africa, we have made a digital spin-off, the name Shape. That is a name of company, and that is several digital solutions that includes predictive maintenance, and that predictive maintenance basically predict the potential failure of a main equipment. And also we have other machine learning as well as combination of very interesting algorithm to optimize the emissions, so CO2 emissions from the facilities. So without compromising any production volume or uptime, what is the best optimum operations to reduce the emissions? So that is other like a machine learning things. And this predictive maintenance is a kind of buzzword over maybe 5 years. So there are a lot of different solutions provided in the market. So like a predictive maintenance, like a easier one to most complicated one. But biggest advantage we have is we have our own operations. So like and interest is directly hitting our own interest. So if we avoid like a failure of the equipment, our uptime is higher. So in combination of those demand and needs within ourselves, and as I said, our strategy is to internalize these things. So Shape has more than 120 employees, and our own digital team has more than 100 people. So maybe in a MODEC group, we have 200, maybe 50-ish digital resources who are working both operation and EPC world. And of course, those like AI is core of technology that in this digital space.
And going forward, do you envision that the industry will employ digital twins and AI for real-time monitoring and predictive maintenance to reduce downtime and optimize operations?
Yeah, I think so. I mean, this twins definition is quite like wide. So twin can be just looking at like a operating condition from shore. So that could be twin. Twin could be like a hull integrity management, like a wall thickness of this external shell is how much millimeter kind of thing. So that is also twin. Of course, this is going to evolve without any question.
Thank you. As our final question, now I'm curious to hear your thoughts on the future and your outlook for this market. What do you think will be the biggest challenges that FPSO design and construction companies and their clients will face over the next 5 to 10 years, and how will they be addressed?
I guess the biggest challenge is the adoption of these technologies and the technology side. Oil and gas industry is evolving of its technologies as well as how it operates. But I guess other disruptive technology, and you picked up AI as an example, that is far, far faster than industry itself in terms of evolutions. So the biggest challenge for sure to come is how we can, for sure, for example, how we can reduce manning offshore. That is not to optimize the man, but more to reduce risk from offshore and to convert like a human resource into more for the nature of the work that human resource is better to do rather than human resource to work as a machine. And then a lot of complicated work as well as the skill required for the lot of experiences now can be partially substituted by machine learning and AI. So the industry-wide, the challenge is how to adopt this one by heart. Of course, how to implement is one thing, but that affects humans for sure. That affects human, even myself. I'm head of business unit, but maybe AI can take over me. Then what should I do? Right? So that is the fear of technology advancement that everyone has. And at the same time, offshore operation is remote, and that is handling gas and oil. That is, I would say, dangerous if we don't do it right. So without sacrificing safety and security, how to adopt technology is a challenge, and how to then convert that things into design as well as management system of the company, as well as the risk management methodologies, and even evaluation of the risk, whether that is considered okay or not considered okay. So that part is challenging from executive to shop floor level, every level. And as I said, executive is not an example. If if I have an agentic AI of business unit head, I will be removed. I can be. So that's a challenge, I guess.
Thank you. That wraps up our Q&A. We appreciate your time and thoughtful responses. This has been a truly valuable conversation. We've covered a lot of ground today, so thank you for being so generous with your expertise.
Sure. Yeah, no, it was really, I enjoyed the talk, and this is my favorite topic for all. So thank you for inviting me for the interview.
Absolutely.